Alright, this is the fuselage or the body and the various parts that are attached to it. Notice here the front of the fuselage, you can see this yellow colored, what do you think that is? What would that be? Or what is it called? I am talking about this part in the front. So this is something that you have to now figure out and tell me what it is. What do you call that part? This yellow colored part on the front of the fuselage. Let's look at types of fuselage. This is the single fuselage type, but can you identify the aircraft? A380. Why A380? How are you so sure? But even 747 is double decker and 4 engines. So you should have said that. First, full cabin length double decker transport aircraft with 4 engines. No need to say 4 engines, there is no other aircraft. Even with 0 engine, there is no aircraft available today which is double decker from length to the tail, nose to the tail. Okay, so this is a conventional fuselage. This one is a twin boom. Now we will not go into the details right now. Why do we? This is twin fuselage, not twin boom. There are 2 fuselages, and notice there are 2 cockpits. So who is the boss? Do you think there are 2 engines? So are these 2 aircrafts welded together to save money? Think about it. And then this is only fuselage. No fuselage, sorry, only wing. This is called as a blended wing body, BWB. This is the shape of the aircraft of the future. What is expected is that in future the aircraft would be like that. Okay. So these are type of fuselages. Okay, let's focus on twin boom fuselage. That was a vampire aircraft, Cessna Skymaster, and many UAVs are like that available. This is the twin Mustang and White Knight. White Knight is very famous. What does it carry? Not the space shuttle. It carries something like a space shuttle. It carries a small aircraft that can be used to give you a experience of near space flight. It's a carrier for another aircraft. What is it called? Come on, you should know this. This is simple general knowledge. Okay, I don't want to tell you. Look at the website of Virgin Galactic and you will get the answer there. It's designed by Bert Rutan. Okay, this is a UAV, Pegasus X-47. This is also a UAV. So what is meant by this APU? Auxiliary Power Unit. So this is the location, right on the back, on the tail, on the rear part of the fuselage. This is where you normally see an APU. In some cases, you can clearly see the exhaust pipe of an APU. So APU basically is a small engine, separate engine. And you can see now the APU has been opened up. So it's a gas turbine engine that provides power for ground operations. It runs accessories and the systems when the engines are shut down. And it also provides the power to start the main engines. Without APU, to start the engines, you will need external power. That means you have to depend upon the airport for providing that much power. So APU is a small starter for the main engine. Okay, now let's look at one scenario. Yeah. On the sides of the fuselage, there are small loops which allow the air to be sucked in. So it's not a jet engine, it's a turboprop engine. So therefore it just needs some air. So there is an intake manifold normally on the sides. Good. Any other question? So let's look at this scenario. During flight, the 2 engines or 4 engines all have failed. Then the APU should help you out. APU also has failed. Can it happen? Can happen. Okay. This happened in a flight called Air Canada. Complete loss of power. So what does the pilot do in this case? Yes, what do you think? So there can be catastrophe and safe landing. So we have RAT. Okay, this is the aircraft which landed safely. So this is what aircraft carry with them. They carry an animal which will provide power. No. RAT is a ram air turbine. It's a small turbine that comes down below when needed, and it gives the required power. So I have lost all the power and I don't have a RAT with me. Okay, so it generates power from the ram pressure of airstream. The small fan which is mounted below, this fan will start rotating. When it picks up some minimum speed, it will start generating power. And the usual location of RAT, this is where the RAT is. You will see, this is how it comes out and starts rotating. And this is for the ground, for maintenance purposes. This is how it goes back inside. Alright, so we also have something called as a tail skid. It's there. Yes. Ram air turbine. Yes. So ram air turbine is only able to give a small amount of power which can only run the main functional components. It cannot run everything. So it will run only one hydraulic system which is required for safe landing. It will not run air conditioning, unlike APU. It will not run other passenger entertainment systems, movies, etc. May not run. So it's a small turbine for emergencies for just the minimum power. Okay. Yeah.
Ram air turbine, don't we increase the drag?
But what is the option? Everything else has stopped working. Now I need something that works like a windmill, purely on the function of the ambient speed of the aircraft. And I want it to be completely independent. It should not be connected to anything. So the ram is lowered by the pilot manually. There is a ram deployment lever. It's not deployed hydraulically because you can assume there is no hydraulic oil or no pressure available. So sometimes there is a small wheel or there is a jack or a kind of a lever. So they want a system which is completely self-sufficient, which can bring the aircraft down safely in emergency.
So what exactly will it power? The control surfaces? Or?
Yes, it will power one of, see, an aircraft normally has 3 hydraulic systems. Okay, we call them as yellow, blue, green. So it will power one of the control systems which will be connected to the primary flight surfaces. So it may move only one rudder, only one inboard ailerons, okay, may only move some flaps. So it will be used to power only the minimum things required for a safe landing. So therefore the power requirements are also limited. All the emergency systems that you need, landing gear retraction, extension, it will be powered by RAM. Otherwise everything is fine, but you cannot come down. Okay. Sometimes it doesn't work also, sometimes it doesn't give enough power. Those things also happen, but they wanted to have a system so that in case there is a situation, then we have something. Okay. So tail skid is a very interesting device. Obviously you can see that tail skid is essentially trying to, what is it doing? Avoiding the rubbing of the fuselage on the ground and very costly repairs, for which the aircraft has to be shipped to the manufacturer. So what you do is you have a disposable kind of a skid, it rubs. But why is it needed? Why will an aircraft go at an angle such a large that the fuselage will hit the ground? When can it happen? Yes, loudly please. That means in a large aircraft, routinely there is a tail skid which gets burnt away. If I say that it is used mainly in landing, then yes, you what you say is not wrong, it's correct, but that's not the main driver. Yes, loudly please. Okay, some kind of disturbance. So this is not something that you desire to happen. Okay, it's like a safety device. Okay, when it happens, this is a trial flight. You can see it starts hitting.
Ça touchait pas un moment. Ça touchait un moment. Je peut-être pas. Et toi? C'est parfait.
The second run appears to be a success, but with time pressing, the ground crew races to the aircraft to discover that despite a more controlled takeoff, the shredded skid will need replacing once more. Unfortunately, there's a limited number of the specially engineered skids available, so the crew know that they can only afford.
So this is the tail skid, which has got this portion which can be worn away and replaced, but as you saw in this test, even the rear fuselage end scraped little bit, and because of that they have to now change the skin on the bottom.
To use one skid for every 2 runs. From this point on, even the slightest error could put the entire campaign on standby.
This is that skid. Which wears away. Yeah. Small. And that wheel will break and go inside the fuselage because of the high impact. So they have decided that the best way to overcome a very bad situation, even with the skid you saw that the rear was slightly damaged, but imagine if there was no skid, then the whole of the rear fuselage conical thing would have to be changed. Yes. No. The skid contains material which will wear away without damaging the runway. So it uses cork or some other such material. It's a very interesting thing. In fact, it's one of the challenging materials to be used. What is the material to be used so that the aircraft is protected but runway is not damaged? So it's a very interesting material, and a lot of research is done in designing or identifying the suitable material for the tail skid device. Okay, let's look at the radome. Radome is basically a cover. It's like a nacelle again. There is a radar inside the aircraft. You put a cover over it. It's called as a radome. And it has a antenna. You can see the radome covers this antenna. This antenna is for which radar? What kind of radar is this? Yes? No, it's not omni because it's not going behind, it's going only 180 degrees. It's a weather radar. This is a transport aircraft. They don't have to hit any targets or drop any passengers somewhere. They are basically going to scan the weather ahead of them. So therefore it has to move 180 degrees. And if you don't have the cover, you know what will happen. So just to cover it up, you have this radome. Hence, the material in the radome has to be radar transparent. So One of the first modifications that was done by us in India was to, when we worked on the Dornier 22 aircraft in Kanpur, was to build the radome in India. A very expensive radome used to come from Germany. So a small composite laboratory was set up. Radome is a non-load carrying body except for the loads which come in the front. Okay, it does have aerodynamic loading, but it's not impact load or something. So we were able to do it, and we were able to save a huge amount of foreign exchange. Instead of buying it from the Germans every time, now we make our own radome, and after that we began supplying radome to other countries and other places also. Okay, these are the stabilizers. Stabilizers basically are moving surfaces, either partially moving or fully moving, on the rear of the aircraft, which allows it for the longitudinal balance. This is the longitudinal axis. So to avoid uncontrolled pitch, we have stabilizers. So now let's see also a small film on trimmable stabilizers. You can see here, you can actually adjust the whole surface to provide the required moments. So this is not moving in the air during flight. During flight only the rear portion moves. This is adjustment of the whole thing on the ground before the flight, adjust and lock, so that you get a constant moment to balance it. Yeah.